All right. So, like I said earlier, in this class, we'll be looking at interaction with users, which ends module 2. We'll also look at Boolean values, conditional execution, loops, list processing, logical and bitwise operations. Then we'll move to module 4, which talks about functions, tuples, dictionaries, exception, and data processing. So we're going to be starting with user interaction. So user interaction in this sense is just using Python to permit a user to, give a command or make an input to your code. All right. So for example, in this code here, we have print tell me anything. And now we now have a variable anything. And in this variable, we are supposed to receive an input from the user. So this is the function to get an input for the user. I use the input statement, and you put the brackets. Remember I said earlier in our previous class, if you were not there, you have to go watch it. You can watch it from the YouTube channel. So every function carries a bracket after it. All right. So this particular input now reads strings from the standard input. You can see if you're using an ID, some IDs come with all these hints with them. So you can always look at the hints that comes here. So now this input is going to get something from the user, and the user types anything. And we're going to print out what the user types by what? Printing first the string. Then the variable anything. We discussed variable in our previous class, and also really. So now if we are going to type, let me close this terminal and open a new one. So I'm going to run the code now. So now as you can see, it says tell me anything. Now I have the ability to type something. You can see now I can make inputs. All right. So I'm going to write something, and I'm going to hit the enter key. Now you can see it now prints out what first, then the value of what anything, which is what I imputed, which was what something, and prints out what really. So that is exactly how the input function works. So that there we have an argument. So one thing you need to know is that the input function can prompt the user without any help from the print, right? And also the input function can carry an argument without, like, instead of having an empty braces. So another thing you need to know is that whatever you type inside within the input function comes out as a string. All right. So by default, the content from the input is a string. If you wanted it to be an integer, you have to convert it to an integer, but we're going to get to that later on. So now we're going to try something else. This time around, let's erase this. So now I have anything equals input. Now we have a string inside it that says what? Tell me anything, which means that if I should run this code, it's going to first of all print out what? Tell me anything. So remember before, we had print tell me anything, right? But this time around, we're going to take this out, this first print statement out, and have that tell me anything within this input statement, such that when I run the code, so I'm going to run the code now, you see something. Sorry. So let me correct that. So let me run this again. So now you can see here that it says what? Tell me anything first before it allows me to put an input, right? It says what? Tell me what? Anything. I have tell me anything here. So here I can now type whatever I want to. Let me take this up a bit. I can now say something. Now you can see now prints out what? Something. Really? So sometimes, you know, those simple games that you just, all those probably Nintendo games, they'll ask you, what is your name? Or impute your age, you know, those kind of stuff that can appear in all these LED screens. So you can just say, what is your name? Or let me use impute your name. And I'll put space there. This time around, I'm going, instead of putting anything, I'm going to change this to name. So right here, anything is not defined, so I have to change it to name. So we have name here. And here I'm going to say, welcome, or let's say hello, then the name. I'm going to put a space there and then say, actually, there's no need for the space. Welcome to name. So now, when I run this code, impute your name, do you now see? Just like a normal game will work, and I'll say Rollins. Now you can see, now say hello Rollins, welcome to the game. So that's how some of all these basic games work, where they ask you to impute this, impute that. So automatically, because you find out that for the rest of that game you are playing, it's going to be using your name. That's because your name has a stored in variable what name within that game. All right, so now let's look at something that might give us an error, right? Let's look at something that is going to give us an error. So I'm going to edit this and put this. Now, remember I said that everything that enters into the input is what? Considered as a string. So now, this time around, I'm taking an input for anything as a number, and I'm going to add what? Something, and multiply that number by what? 2.0, right? Okay, make it raised to power what? 2.0. So which means anything to the power of 2 is what? Something. Do you understand that? So we're taking in a value for what? Anything, right? Which is going to be our user input, which is going to be a number. And then we're going to put a solution of that number raised to the power of 2 inside a variable called what? Something. And we're going to print what? Something out. So let's try that. So now it says enter a number. And I'm going to just enter 4. And I'm going to hit enter. Now it's going to give me an error. You see, it's going to give me an error. Now the error is what? Unsupported what? Operand what? Type for power. So string and what? Float. So which means I'm trying to what? Use string raised to power what? Float. And it's not possible mathematically. It's not possible in Python. So use string to the power of a float. So you cannot use string and a string to multiply a number or an integer or a float, right? So which means we are going to have to correct that. And for us to correct that, we are going to convert that input to a float or to an integer. And for us to do that, we are going to add something here. Instead of us to put input, we're going to put float, right? And open it up and close it here. So now, when I run this again, let's see. All right. So I'm going to put a number there, 4, and I'm going to, you can see now, 4 to the power of 2 is what? 16.0. 4.0 to the power of 2. So now this 4 has been converted to a float because we are converting it to a float first. We're converting whatever the user imputes to what? A float. So which means we can convert numbers that are strings into floats. We can also convert them to normal integers, right? So if I should use int here instead of float, right? And let me hit this again. That is new. So now you can see enter a number. I can say 5, and you can see now it's not 5.0, it's what? 5, because 5 is what? An integer. Our converted to integers. When we convert it to float, it's going to change to what? 5.0. But now we're multiplying by a float. Remember in the previous class, we said when you use a float to multiply an integer, your result will always be a float. So 5 to the power of 2.0 is what? 25.0. So that's it about that. Let's look at another. Let's try to use it to do a simple mathematical operation. So this time around now, we are going to perform a mathematical operation. All right. So we'll eventually be able to write complete programs accepting data in the form of numbers, processing them, and displaying the results. So these programs now will be very primitive and not usable because they cannot make decisions. But now, that's not what we're looking at. We're just going to try to use what we've just learned, take 2 different inputs. Okay, let's assume that those are different parts of a triangle. So we're going to try to use to calculate the hypotenuse. Okay, so we're going to take leg A as a value, leg B as a value, and now do a simple hypotenuse calculation. So for us to do that, we can first of all impute. I'm going to erase everything here. So I'm going to first of all impute the first variable, say leg A, right? And the next one, we're going to call it leg B. So instead of leg A, so we're going to have leg B here. Then those are 2 inputs and they are being considered as what? Floats. The next thing, we're going to calculate the hypotenuse. And that's going to be leg A raised to the power of 2 plus leg B raised to the power of 2 raised to the power of 0.5. Remember, 0.5 is the same thing as 0.5. You don't necessarily need to add the 0 there. It's just going to give you the answer. So we're going to finally print hypo. So hypotenuse length is what? Hypo. Please forgive my copilot. I think I'm going to turn it off. Next. In our next class, I'm going to make sure it's turned off. All right, so let's run this now. Impute the length of the first leg. Let's say it is 5. Sorry, typing the wrong place. Just type within here. The next one is what? 3. So it's going to give us the actual calculation, which means it's going to what? Take the first one, 5 raised to the power of 2, right? That is what? 25 plus what? 3 raised to the power of 2, that's 9. So 25 plus 9, that's 34 raised to the power of what? 0.5. So that is 1 over 34. You're going to get So that's 34 raised to power 0.5, right? And you're going to get this. Okay, so that's just a simple calculation. And we can also use input to, would I say, concatenate. Yeah, you can use input to concatenate strings. For example, you put in first name, put in last name, then you now say print full name. Okay, so we can now say, let's erase this. You can say first name, let's call this F name, equals what? Input. Then we'll put a string. What is your first name? Okay, my copilot is doing well. Then you can call the last name, L name. So it says what is your last name? And we can now print out the both of them and say what? Hello, then your first name plus what? Your last name. Now, concatenating string is just simply adding a string to another string. So using the word plus. Now, if you notice, when we put the plus here, all right, after when we put the hello, we give a space, right, before we close the word string. Then we have the first name. The spaces here don't necessarily mean, but after that, we are adding another space so that the two names will not join together. So when I run this, what is your first name? Let's say Oni. What is your last name? Raw or Rex? So you can say hello Oni Rex. So you can see that works. So that's just a simple one. I guess everybody should be able to do this. That's very, very simple. Or this is very, very simple rather. So you can convert a number into a string. All right. If you wanted to convert a number into a string, this is a quick one. Right. This is a quick one. You can say, for example, if you are taking an input, let's say age. Age equals 5. Let's just use a number. That's an integer already. So we can now say my age equals string. So you can see this now. And put, so now this converts this age, which is an integer, to what? A string. Let's say print type. So this type here is going to tell us what kind of value this my age is. So if I should put this, now you can see the class is what? String. My age is what? String. How about if I put age here, right? And I run the code. Now you can see it is what? Integer. The class of age is what? Integer. The type of value it is what? Is an integer, because an integer that was passed here. Let's call this 0.5.0 and print it again. Let's see what that's going to cost. You can see now it has become what? Float. So you can see how that worked when we wanted to convert from string to float. Okay, let's move to the next phase. Let's look at operations, right? Or operators rather. So we're going to start from the equality operator. Equal to operator, when you want to check whether something is equal to something. So in Python, when you want to check whether, for example, we have age 1. Age 1 equals, let's say, 5. Age 2. Age 2 equals 10. Now, print age 1 age 1 age 2. So you can see now the answer is supposed to be false, right? Because let me just erase, it's not important. So it's going to be false because age 1 is not equal to age 2. So when you want to use the equality operator, so let's put a comment here. Using the equality operator. To compare two variables. So now we're printing what age 1 equals age 2. So that's how to use the equals operator. Use what equals. All right. Let's check another one. So that's for the equal to. All right. So the next one is what greater than. We can now say print age 1 greater than what age 2. Now this is what's using the less than or equal to operator. Or no, I think I have to turn off this copilot. This less using the less than operator. All right. So I'm going to do another one using the greater than operator. Now this is also using the less than or equal to. So when you want to use less than or equal to, you put your less than sign and you also add what you're equal to after it. So you can also do greater than or equal to, which is going to be what? This. So that's how all of them works. All right. So there's equal to, greater than. So you can just say equal. Equal to is just like writing this is the same as this. Yes or no? This is the same as this. Yes or no? So if I should print out all these things now, you can see the answers, right? So we have how many here? The first one equal to age 1 equals to age 2. True or false? False. Age 1 is less than age 2. True or false? True. Age 1 is greater than age 2. True or false? False. Age 1 is less than or equal to age 2. True or false? True. Age 1 is greater than or equals to age 2. True or false? False. Then there's also not equal to. All right. So using the not equal to is what? An exclamation mark and equal to sign. All right. So when you do this, you're going to have what? What's the last answer going to be? True, right? Because it is not equal to. Now let's look at conditions in Python. So in Python, when using conditions work like this. So for example, we can now say, in fact, let me just give you the formula first of all. So I'm going to erase all of this. Now, this is how conditions work in Python. You write if, then you put your condition. If this thing is true or not, then you put a colon sign, right? After putting a colon sign, immediately you hit enter. Python automatically indents for you. This is an indentation. This space that is here is about 4 space bar, or you can use 4 space bar or use your tab key to do this indentation. So when you do that, Python is going to automatically what? Indent for you. All right, and give you a space to what? Type whatever action you want to carry out. So if the condition is true, Python is going to what? Carry out the next task that you put under this indentation. So we're going to look at a quick example. This. So we're going to look at a quick example. So now we have this example here. the weather is good, go for a walk. So now, if the weather is good, all right, what should happen? Go for a walk, right? So Python is automatically going to what? Execute this go for a walk if this condition here is what? True. We are going to have another one. So we can also use multiple if. We can also use multiple ifs. All right. So after putting one if, we can do another if. We can do another if again, right? So let me see. So we can have multiple ifs like this. All right. So we can have different if conditions for you to carry out some kind of task in Python. So you have, like, let's say you want to qualify somebody for a movie or a child for a cinema, they have to put some kind of attributes. You can now say, for example, if you do the first one, if age is greater than 18, do what? Go. All right. Let's call this have fun. Then we can now come again. If age is greater than or equal to, let's say 19, or let's say 30. Let's use from age 30 yet first. We have like, okay, go again. So let's assume we wanted to classify people from age 30 and above to watch a particular kind of movie. So that's how you keep on adding those if statements. So now that's just all about the only if, having just if statements. So there's also if else. All right. So
Hello, Mr.
what if
Rollins.
your condition is not met? Yeah, I can hear you.
I'm so sorry to distract. I was raising my hand, but I guess you were not in the meeting space. I'm going to ask you
Okay.
before you delete all of these things. Is there a way you can just send it to the chat so we can always copy it as our own personal reference, so you can just practice with it too. Like before you delete like this conditional statement that we're working on now. Before you delete and do
Okay.
the next one, if you can just copy what you just have and
Okay.
paste it in the chat, so I can just copy it to my own VS Code and we can just practice this one.
All right. All right. So I'm going to do that now. Okay, so I'll just have it open by my side so I can watch it. All right. I've sent that to you. So now this is just for if. All right. So now let's look at the if else. So the if else works like this. We can have our condition, right? We can have something like this. If you have a true or false condition, all right, you are going to perform what? An execution. All right. But that's if the condition is true. Python is going to perform what is written in this indentation. But if the condition is false, Python will jump to the else statement and perform the condition if the statement is what? False. So this is your primary condition here. So, and this is your true execution, and this is another execution. So that's how the if else work. For example, if we are to, let's say, age equals, so now let's say that if, remember, we dealt with our condition operators, right? So if age is less than 18. All right. What should happen? Let's execute something. We'll say print this program is not for you. Or else, what should happen? Print, go ahead, or we're supposed to use a string. You can watch this program. All right. So now, if I should run this code, now, you can see now it says what? This program is not for you. That's because the age is what? 14. Let's assume the age is 25. All right. Let me send this to you. If the age is 25, you can see it has gone to our what else condition, and it says what? You can watch this program. So these are how some filters are being done on applications, all right, on YouTube, all right. You know, when there are some violent scenes in the news, they are restricted for younger generations, all right. So that is for the if statement. So there's another one again. You can have an if statement under an if statement. All right. You can have an if statement under an if statement. So for example, let me use this formula for you. So if the weather is good, then under that, we now have another condition. Nice, if nice restaurant is found now under that good weather, all right, what should happen? Have lunch. If you don't see a nice restaurant, what should you do? Eat what? Sandwich. Then if none of this works, or for example, if none of this works, all right, or if the weather is bad now, if this primary condition here not working at all, or is not true at all, it jumps immediately to the else and says what? If tickets are available, go towards the theater, else go shopping. So it will perform all these conditions. I'm going to give you an example. So we're still going to be using the age. Let's start from scratch. So age equals 14. Now, let's assume some children went to the amusement park or to some kind of festival where they have a lot of equipment, a lot of fun stuffs. There are some fun stuffs that they won't allow children to try, some kind of scary stuffs or some kind of dangerous stunts, or maybe where they are going having some alcoholic drinks. They won't allow children to go there. So let's see if we can write a small Python code for that. We can now say that what if age, all right, let's start from um the let's say adults now. If age is greater than or equals to 30, don't forget you must always put your colon. If you don't put your colon, Python is going to give you an error. And if you don't put your colon, when you hit enter key, you're not going to get any indentation. Let me show you. So if I don't put colon and I put enter, you can say I don't have any indentation. But I have to put colon first. Then before I use enter, I'm going to have an indentation automatically. We'll now see again, if age is greater than or equal to 50, we'll now say what? You are old. You are, let's say, too old. All right. Else, print you are what? Old. You are old, but would try this stunt. Okay. So now we can also have we can now have the else, right? If age is greater than or equal to 20, you are young, but you could try this stunt. If the age is than 20, you now say you are too young to try this stunt, right? So let's run this code now. What do you think the result is going to be? Anybody? Before I run the code. Since we have age here, 14, what do you think the result is going to be? You can use the chat section because I can see it. I'm going to add this code for you. So let's run this code. You can see it says what? You are too young. Let's put in a value that makes it what? Greater than 20. Let's say the person is 27. Now you can see now it says what? You are young, but you could try the stunt. Let's assume the age is what? 30 plus. Let's assume 35. And I'm going to run the code. So now you can see it says what? You are old, but you could try the stunt. Oh, let's try 50 plus. So let's say 56 and run the code. You are what? Too old. So you can see our code runs. So this is how some filters are being generated. This is just the basic idea, right, of how some kind of filter works. So there's also something called the elif. Let's assume you want to check for multiple conditions, whether before you carry out an action, all right, or you want to a series of action. Okay, you want me to explain the line 3 and 4 again? So this is our primary condition here. All right, these are primary condition. And now it's supposed to carry out if this condition here is true. Python automatically jump into everything that is under it, everything that is indented. All right, you can see everything here has spaces by their side. So which means they are all under what? This if statement. If I should minimize it, you can see everything as hidden. So they are all under this if statement. All right, so everything here that is under this particular if condition here. So if this condition is true, all right, Python automatically jumps inside here. Now this is also a condition, and if this one is true, Python is going to carry out this. If this is not true, Python will jump towards the else statement here and carry out this. But what if this is not true at all? If this is not true at all, Python automatically leaves everything here and jumps towards the else and jumps to everything that is under here. And now come and check for this next condition and checks if it is true. If this is true, it carries out what is here. But if this condition is not true, it comes towards the last else statement. So if I should minimize it, you can see it has, you have your if, you have else. So if this is true, it automatically jumps inside. All right. But if this is false, it jumps it and comes to the else and carries out whatever is inside the else. All right. So that's just how it works. So I have put the code for you in the comment section to copy it, so you can check our chat section on the meeting. So we're looking at the elif, right? This is how the elif works. This is just a simple example. All right. So there are some things that you should pay attention to. You must use else without a preceding if. All right. You must, else is always the last branch of this cascade. All right. So else always comes last. You can have multiple elif before the else. All right. For example, if this is our primary condition, if this is not true, it jumps to what? The next what? Elif. All right. If this is still not true, it jumps to what? The next elif. If this is not true, let's assume this is the last condition you want to check. You now it's just jump to what? The else. So the else must always come last. The else must always come last. All right. Also, the else is optional. Okay. You might not even need to put else. You can even decide to remove else. What if you have put all your conditions? You can decide not to use any else at all. All right. It's very optional. And also, if there is an else branch in the cascade, only one of all the branches is executed. If there is no else branch, it's possible that none of the available branches is executed. So this might sound a little bit puzzling, but um, let's look at, we're going to look at a simple example. Just trying to see if I can get something very, very, very basic. Okay. Let's still use this age sample here. So we have, let's say this is a movie theater. Age equals 13. If age is less than, if age is less than or equal to 12, we can say you are a child. All right. We can now say Elif, age is 19, less than or equal to 19. You are what? A teenager. Elif, age is less than or equal to what? 59. You are what? An adult. Else, print, you are a senior citizen. Oh, I love AI. So everything is just giving me a sweet recommendation. All right. So now this code here is actually going to classify individuals according to their age. All right. Okay. It's already written here already. So this code above is simply an age classification program. So here it's going to check if the child is what? Classify the child according to his age. So if the child is 12 years, you now put what? You are a child. If the child is from 13 years to what? 19 years, all right, it will write what? You are a teenager. If the child is what? 59 years and younger, that's from 20 years to 59 years, it will write you are an adult. And if the person is over 59, that's from 60 and above, right? You're a senior citizen. So if I should run this code, let me, so you can see you're a teenager, right? What if I put 18 or 16? Okay, let's say 4, all right? And I run the code. You are a child. You see that? What if I put 45? You are an adult. Okay. 75. You are a senior citizen. So you can see how that works. Very easy. All right. So that's exactly how the conditions work. Okay. So next we are looking at loops. Okay. Looking at loops. we're going to have use the start from the while loop. All right. So while works like this. This is a simple formula. Okay, I'm going to give people access to this too. So this is a simple while formula. While is a loop. So a loop, right, is something that happens over and over again until a particular condition is met, or a particular condition, yeah, until a particular condition is met. So for example now, while there is something to do what? Do it. So while this condition is still true, all right, continue doing this thing. So Python automatically continue doing it and doing it and doing it and doing it. If there's no, if this thing is never met, it will continue, it will be stuck in an infinite loop. Okay. So you can also put different instructions. So for example, now you can have this. While this put your expression, your condition, Python will do what? Carry out the first instruction, carry out the next one, carry out the third one, and continue carrying out all instructions until the last instruction before it jumps out of the while loop. So you can have multiple instructions inside a while loop. Let's look at an example of an infinite loop. So if we carry out this infinite loop, for example, now if you try this on your code, let me clear this. Let me delete this name now. So you're going to see this infinite loop. You see that my code will continue running and it will never stop while true. So you can see now I'm stuck inside a loop. I'm stuck inside a loop. I'm stuck inside a loop. It's going to continue printing until maybe I press an interrupt. So when you, your program or your game gets stopped, and probably the game just start glitching, you see the things carrying out only one particular action over and over again. It's just stopped there. You'll not be able to. The game has been stopped in a while loop. That's a glitch. All right. The game has been stopped in a while loop. So that particular game character can just be carrying out only one particular option. So that's how some games work, some NPCs work. So you see them, no matter how you hit them, they'll just say one thing. So they just say one thing like that. Sometimes when you now start seeing that particular NPC saying one thing without anybody hitting it, just know it has been stuck. It has been stuck inside a loop. All right. Without any other, you didn't hit it the second time. You just kept on saying the same thing, saying the same thing, saying the same thing, saying the same thing. It's just like it's stuck in a while loop. So one way to come out of a while loop is just by pressing the interrupt key. All right. So now I've just pressed my interrupt. I use Control C. You can see keyboard interrupt. Control C stops my code from running. So that's an example of an infinite loop. So let's look at this simple code here. Um, so this program now is going to read the sequence of numbers and count how many numbers are even and how many numbers are. So the program terminates when 0 is entered. All right. So we have odd numbers. So the odd number is 0. The even number is what? 0 at the initial instance. So now you're going to enter the first number. So you're going to, Python is going to tell you how to continue. It's going to keep on asking you, enter a number, enter a number, enter a number, and it will continue telling you whether the number is even or odd. All right. But when you now terminate the program, you terminate the program, when you press 0, all right, when you press 0, the while loop is automatically what? terminated. So you can see the condition here says what? Number is not equal to 0. Remember I said not equal to is exclamation and equal to equal sign. All right. Number is not equal to 0. So as long as the number you are pressing or you are inputting is not equal to 0, all right, the while loop will continue running. All right, the while loop is going to continue running, and when it runs this, it will ask you again to what? Input a number. So now let's look at this. If the number, let's study this condition. So if the number divided by 2, remember an even number is when you divide it by 2 and there's no remainder. All right. So if you divide by 2 and there's a remainder, all right, automatically what is an odd number. So it's automatically add 1 to the odd number. I explained this particular thing in our previous class. All right. But if it's not this, it means that you're going to use else, and automatically you know it's an even number. So let's run this code and see what happens. All right, so it tells me what? Enter a number or type 0 to stop. So I'm going to keep on entering numbers that are not 0. So 12, it will tell me to enter another number again. 14, 3, 75, 25, 24, 33, let's say 87, 17, 20, 12, 13, all right. And so I'm just entering random numbers. So I'm just going to enter random numbers. So I want to stop now. I'm going to use 0. So once I hit 0, now it stops. Now I typed a total of what? 11 odd numbers and a total of what? 8 even numbers. You see that our code works. So that's it about the while loop. So let's look at range now. We're going to look at the for loop and the range function. All right. So this is how the for loop and the range function works. So I can have, let me copy this for you so you can have this too. So you can have this. This is how the range function, the range loop works. So the for loop works. The for is a loop, all right? The for loop, this for loop, and you're going to use the range function together with the for loop. So now, for I in range, print what? I. So this is a list of numbers, all right? But now, range is telling us the range function works like this. It's going to start from this, all right? And it's going to limit end in what? 8 and increment by. Let me come here so you see it very well. So we have the range. It's going to start at what? You can see when you have range, you have the start number, the stop number, and the step. The step there is how many steps you want it to go to skip before it goes to the next number. Let's run the code so you understand better. So now, for range in 2, 8 with a step of 3, the value of I is currently 2. So it starts from what? 2. So which means we are going to have 2, all right? After 3 steps, we are going to have what? 5, right? After 3 steps, we are going to have what? But now, it does not stop at 8. It stops at what? 8 minus 1. All right. So it does not stop at the exact value here. It stops at the exact value here, minus 1. That's why it did not, if not, that put what? If I should change this now to 9. So if I change this to 9, you're going to see that, let me erase it so it doesn't give me an error. You're going to see that it will write 2, 5, and 8. So you can see. Do you now understand better? So it is n minus 1. This is n, all right? Okay, this is A, this is what? B. So B minus 1, not just necessarily B. And this is what? C. C is what? The step. That's how the range works. We can also do range without adding step. If you don't want to add step, if I should remove the step, it's going to automatically increment by 1. So by the time I do this, you're going to see it 2, 3, 4, 5, 6, 7, 8. Do you see that? If I want to add increment, I'm just going to need to just type what? Minus what? 2. I saw a comma and 2. And we have this. So instead of having 2, 3, 4, now we're going to have 2, 4, 6, 8. You see 2, 4, 6, 8 as our result. So that's exactly how the range works. Let's look at the break and continue statements. All right, the break and continue statements. I'm going to use a quick example. So now, let me erase this one first. This is a break. So you're going to, using that same range, remember I said the range work. This is the start and this is what? The end, minus 1, right? So if I is equal to equals 3, break. So which means you are going to enter inside the for loop. Remember, this is our condition. This is a loop, right? And whenever we have a condition, it enters inside the loop and performs whatever instruction that is here, all right? But once the instruction is complete, all right, once this instruction is complete, it goes out of the for loop, right? So now we're going to use this to, we are going to use these two statements now. I am inside the loop, for us to know that we are still inside the loop. All right. So now let's look at this. If I should run this code, Python is going to count from range 1, start from counting from 1, 1, 2, 3. So the value of I is going to keep on changing from 1, it's going to change to 2, it's going to change to 3. But when it gets to 3, you can see we have an if condition here, right? So once the Python notices that the value of I is 3, it automatically breaks the loop and now goes outside the loop. Look at this. You can see I'm inside the loop, right? I'm inside the loop 1, inside the loop 2. Making it is 3, it now jumps. It did not print 3, it now goes what? Outside the loop. Do you see that? So immediately Python found out that I was equal to 3. It was broke there. It did not even print the value of 3. Immediately it jumped outside the loop. So we have the continue here now. Now, continue works like this. Let me erase that of break. So if I should run this continue now, you can see inside the loop 1, inside the loop 2. When it got to 3, it performed what? Continue. It did not what? Print the third one. All right. It now jumped. It jumped the what? Third value and went to 4, 5 before it now went what? Outside the loop. That's exactly how the continue works. Um. Let's. Is there any questions? Are there any questions so far? Before we move to logic. Okay. So we're going to use logic. Remember, if you did your science, then you did logic, you know, the AND gate, the OR gate, the NOR gate, the NOR gate. All right. So those are logic operators. All right. So we can do this and this. What's the answer? I know logic operators compute on and off. All right. It computes true or false. On is 1, off is 0, true is 1, false is 0. That is exactly how computer carries out all its computations, all its operations. Everything that you type in a computer, every communication you do in a computer automatically translates everything to either on or off before it can do anything. So we're going to start from the AND. We're going to start from the AND. All right. So the AND has um I'm going to have to draw. I'm going to have to draw on this. Okay. So let's assume we have um, two inputs, the input A and the input B, and we have our outputs. These are outputs. So remember I said it's always on or off. So we have on, off, we have off, on, we have on, we have off, off. So these are the 4 different possibilities that can happen whenever we are on and off. All right. So for the AND operator, when it is on and off, which is true or false, all right, is always what? False. Whenever we have false and true, it's always false. Whenever we have true and true, that's the only condition we have what? True. When we have false and false, we have false. Now I'm going to explain with this. Let's assume we have a light switch, something that's also on a light bulb here. All right. So we want to turn on this light bulb, and the light bulb has 2 switches. Okay, no, this is not, sorry, it has 2 switches, one here. This is how the AND is. So this is switch A, and this is switch B. Now, at the moment, both switches are off. The only reason why this bulb is going to on is only if these 2 switches are on, because even if you turn on A, B is still off, so the current is not going to pass. Let's assume this is where our battery is. Once you connect the battery, right, and you turn on this switch A, as long as B is off, this bulb is not going to come on. So which means that if A is on and B is off, we are going to have off, right? If A is off and B is on, right, we're still going to have what? Off. But now when you on both of them, which means that current can now what? Pass. Current can now pass. All right. It will pass through A because A is on, B is on, not B is on. It will now pass through B and the bulb is going to on. That is the only condition you are going to have what? On. But if both of them are off, automatically the bulb is going to be what? Off. So that's exactly how the AND operator works. So I'm gonna erase this. So we also have that for the OR. For the OR operator, for the OR operator, let's say we have A, we also have B, then let's assume C is our output. So we also have what? Both of them off, both of them, okay, one on, the other one off, this one off, this one on, both of them on. All right, so that's how both of them works. So if we have this, for the OR operator, is it that any of them has to be on for the output to be what? On. So for example, both of them are off, right? So we are going to automatically have 0. For the OR operator, just one has to be what? On for our output to be on. So we have A is on, B is off. So automatically we have what? On. A is off, B is on. We have what? On. A is on, B is on. You also have what? On. So the only condition that we will have our output as off is when both of them are what? Off. So that's for the AND. So the NOT, for the NOT, right? The NOT just works by, it just negates the original value of 1. So if we have, so if we have 1, not 1, all right? When you not 1, you're going to have 0. When you not 0, I'm just using this, sorry. When you not 0, we're going to have what? 1. So the not just what gives you the opposite of a particular input or output. That's how the not works. All right. So forget all this my big grammar. We're gonna have to do something. All right. So we're going to have to do something. So for example, now let's look at an example of this not. Let's look at the example of this not. So we have this. If var, let's assume, because I've not defined var, if var equals to 5, remember we're dealing with 1 and off, all right, 1 and 0. So if var equals to 1, so for the first example, var is greater than 0. True, right? But not var is less than or equal to 0. Let's see what's going to result. And we also have var not equal to 0 and not var is the same thing as 0. So automatically, if we should do this, var is greater than 0, right? This one should give us true. Our first answer should be true. var is less than or equal to 0, false. But we're not in it. It's still going to give us what's true. So we have true here. var is not equal to 0, true. var is the same thing as 0, which is false. And if we not it, it's going to give us what? True. All right, let me clear this so we can have a fresh start. So you can see all our answers are what? True, like we calculated. So that's exactly how not works. Let's look at another one. This one is a little bit more complex. I'm gonna so we have this. I'm going to define the value of P. Remember I said you can define P and Q like this, comma Q equals 1 comma 0. So now I've assigned value for P and Q. All right, so you can do this. So P automatically takes value of 1, Q automatically takes value of 0. So P and Q. P and Q. Remember, I told you the and. Two of them has to be on for your answer to be what? On. So two of them have to be true for your answer to be true. So P and Q, they are not, both of them are not Q. So the answer is going to be what? False, right? But we are noting it now, which means not P and Q is going to be what? True. So we're having true here. This one automatically gives us, let me use a comment to type us. So type is true equals is what? False. Not Q is what? True. We're having or. So one or off is what? True. So this automatically gives us what? True equals equal true, which means our answer here is going to be what? True. Let me give you access to the other one. So let's look at the next one. P or Q is what? Automatically true, but not it is what? False. Not P is what? False. And we're having and. Remember and. Both of them have to be true. Already not Q, not P is already false. So which means our value here is going to be what? False. And automatically false equals false, which the answer is going to be what? True. So that's already our answer. So if I should run this code, you're going to have true, true. So if I should print, let me print this. Sorry. So also print this. Oops. This um this Copilot is worrying me. So if I should print this, we have true, right? So our answer is correct. And then we also have bitwise operators. So this just works like our logical operators, right? So we have our bitwise operators include our ampersand. All right, we have ampersand. This is and. We have the bar. We have the caret. We have the caret, and we have the tilde. So we have, where's my caret sign? Okay, and we have the tilde. So that's the tilde. That stuff that looks like a sideways S. All right. So those are the ampersand is conjunction, the bar is disjunction, the tilde is negation, the caret is exclusive or. All right. That's the computer program. I'm not going to dwell on this for too long. So I'm just going to give us what we should expect as the result. So for example, now I'm going to draw a table for us. So let's assume we have this long table. We have our inputs A. We have another input B. For our next, we have A and B. All right. We also have A bar B. We also have A then caret B. So we also, for our inputs, remember we are doing 0, 0, 0, 1, 1, 0, 1, 1. So A and B just works like the AND gate, right? Two of them has to be on. So we are going to have 0, 0, 0, and 1. A bar B works like the OR gate. So we have 0, 1, 1, 1. A caret B now works differently. If both of them are on, you have false. If both of them are false, you have what? 1. So which means both of them must be different for you to have 1. All right. So both options or both arguments must not be equal. All right. So if 0 and 0 are our inputs, are they equal? Which means we'll have what? 0. 0 and 1, are they equal?
0, 1,
We have exactly is 1,
1,
0 exactly, and
and 0.
0. So that's how that one works. All right. So just something, it's just very, very simple. So let me see. Okay, so I'm going to erase this now so that we can jump to the next thing, which is our lists. So what are lists? Or why do we need lists? For example, you want to go and buy some stuffs in the market. You always create a list, right? So that's exactly how list works. So list has a series of attributes, all right, or a series of content. So list will always have its series of content, and they are majorly strings, all right. Although integers can be contents of a list. And one thing you need to know about lists is that a list is being contained inside a bracket. Remember in the previous class, I said that a bracket, what we call, sometimes we'll be calling this guy bracket. I myself usually make that mistake sometimes. So this is not bracket, this is parenthesis. This is bracket here. All right. So this is what a list is always in. So we have list. All right. So we're going to put our bracket. So we can have a list of number. Let's say 4, 3. So we have this list. So these are the list of random numbers. So that's the content of the list. We can also access different values in a list. For example, let me just say print. Let me use my quotes. Here is my list of numbers. So I'm going to I'm supposed to give a space here. So once I print this, it's going to print out my list, right? So we have here our list. Now, what if I wanted to access different items in a list? Now, in a list, yeah, like now, this list, we have how many items? 1, 2, 3, 4, 5, 6, 7. So I have how many items? So we want to count how many items are in our list. We can use the length function, which is len. We can do this. So you can see we have what 7 items in our list. But now all these no items inside the list, they have index numbers. Now the index numbers within a list, the index starts from 0. It does not start from 1. You know, normally when we're counting conventionally, we start from 1, 2, 3. But in Python, when counting items in a list, you start from 0. So the index of 3 here is what 0. The index of 4 is 1. The index of 5 is 2, 3, 4, 5, 6. So when you count everything together, you are going to get what 7. But if you are counting from the back, we're going to start from -1, -2, -3, -4, -5, -6, -7. So that is how the numbers inside the list carries an index now. So look at, let's say, want to print the item within this list. Let's say print 3, the index number 3. All right. If I should run this code, sorry, I'm supposed to close it. This, so you can see what item has the index number 3? 0, we have 1, 2, 3, which is what 6. So I should change this number here to -2. What is going to come out? 8. 8 is going to come out if I'm trying to print -2. So you can see 8 came out. That tells you that when you're counting from the back, you start from -1. When you're counting from the front, you start from 0. So you can also insert items inside the list. All right. So let's assume we want to insert an item into the list. We can say list dot append. We want to add an item to the end of the list. We use list dot append. So I'm going to print out list again. So you see that 10 has been added. So once I run this, you see now, here is the list of numbers, which is our output here, which carries what the original. Let me add original here. All right. So we use list.append to add a number, an item to a list. All right. So you use, if you want to remove an item from the list, all right, you can use the pop. All right. We can also change an item inside the list. If I wanted to change an item inside the list, I can actually use list and put the index number where I want to change. Let's say I want to change 5. I want to change 5 to 11. So I'm going to 5 carries the index number what 2. I'm going to put 11 here. Then I'm going to print my list again. So you see that the item 5 has been changed to 11. So you can see now 5 has changed to what 11. That's how to impute an item. All right. You can also compare, compare the values of the list, just like you're checking the index number. You want to check if this index number is equal to so that index number. You can say, for example, list this equal. You want to check whether the index number 2 is the same thing as the index number 3. All right, that gives you true or false as your answer. All right, I'm supposed to put this inside a print statement. Okay, so you can see we have what? False. So you can use conditions within your list. All right, and here's an example of using accessing the list with a negative number. I'm going to have this. So if I put -2 here instead, and put, remember -2 is what? 8, and I put 11 in place of 8. When I print my list again, you see that 8 is going to change to what? 11. So you can see now the value of, okay, sorry, remember we added a number here, so we're going to have 10. So 9 is going to change to 11. Let me erase this. So we get our desired result. So now you can see that 8 has changed to what? 11. What else have I not touched within list? So I've touched append. I've shown you how to check for I've shown you how to check for a number, how to add a number. So I've not actually showed you how to remove a number. All right. So you can also remove a number. You can use the pop option. So I can come here. Let me remove this. List dot pop. So you can see all, if you're using an ID, it should show you all of them. You can see append, you can use clear, copy, count, extend, insert, index, pop, remove, reverse, sort, right? So if I should use pop, if I don't put anything inside, it's going to automatically pop the last value, all right? And I print my list now. So you can see it has popped the last value, which is 9. But if I should insert the index number, let's say 2. All right. So you can see it has removed what? 5 from my list. If you want to print the actual number that you popped, all right, you can just say print, then you put that particular pop command inside your print statement, all right, when you run your code. So you can see it popped what? 5, right? And our new value of our list doesn't have 5 there. Okay, you can keep exploring other inbuilt functions within the list. Okay, let's see. Let's look at another option or another example. So we can update our list. To update our list, I'm going to use this one as an example. All right, here we have our list, and inside our list we have different values. We have one, we have none, true. So a list can contain integers, floats, strings, booleans, right? For example, we have booleans here already. We have strings, we have integers. Okay, it can also contain floats. So we can say print my list. So this inputs, this outputs what? The index number 3, which is I am a string. This one outputs what? 0, which is from -1. My list underscore 1 equals what? So this one automatically changes the value of what? None to what? Minus, to from of none to what? The question mark, right? Then we also have list.insert. We put 0 comma first, list.append last. So now this one automatically what? Puts first inside the what? First index. The index here is what? 0. That's how insert works. All right. When you put insert, you're going to put the index number. You can put the index number first. If you don't put any index number, it's going to automatically replace the first index. So when I run this code, let me delete this. So you can see now first has appeared here, and append. So insert from the front. You can use insert or to insert in a beginning or in the beginning. Now, insert does not replace an item in the list. All right, it just fixes an item in whatever position you want, and it does not replace the item that was in that position. It automatically what pushes others forward. So for example, now insert first, you can see first entered here, but one is still there. One is just that one, the index number of one will not change. It's no longer be 0, it will now become 1. And first is going to carry what? Index number 0. Append also will now push everything other backwards and carry the index number -1, or whatever last number is the index number there. I think that's all for you. We can also sort lists. We can also sort lists. If you do list.sort, all right, it's going to sort the list. But there's something called bubble sorting. I think I want you to read that up. It's actually on the course, fully explained. All right, there's a lab with that particular bubble sorting there. But if you need any more clarification, you can send a message on the Discord server and I'm going to respond to it. All right, so let's look at slicing. So you can slice a list. All right, you can slice a list. So let me say, I'm trying to remember how that range worked. Remember how we used range to do some certain things. We can also use list to do that. Only that this time around, we're not going to add range. All right. So here we are going to use this to slice our list. So let's say instead of me putting my list here, let me call this my new list. All right, so we have this. Oh, I think it's already there. Sorry about that. Oops. It's taking stopped presenting. Sorry about that. Let me share again so that you can see my screen. Yes, can you see my screen? Can you see my screen?
Yes, I can see your screen. Can you hear me?
All right, all right. So we have this.
No, you just stop sharing now.
Okay, I've rectified that. So now, I guess you can see my screen now.
Yeah, you can see your screen.
All right. So we have our first list 10, 8, 6, 4, 2. Then we have a new list now. This new list, we are going to slice part of this first list and put it inside. And if I should print this, if I should run this code, our new list is going to have what? 8 and 6. Why? Because it's going to start from the index number 1. Remember how range works, all right? It starts from the index number 1. So what's the index number 1 here, which is 8, and stops at the index number 3 minus 1. So automatically it's going to stop at the number with the index number 2, not 3 exactly. So remember I said this is A, this is B minus 1. If you want to add step, you put ratio, you add the step. So if I should put this, all right? If I wanted to put all right, so if I had more numbers here, let's say 2, 4, up to 10. So, and I put stop at what? -1 at the end, right? And have a step of what? 2. So you can see this will take every second element starting from the index number 1 and the second step. So now it's going to stop at what? 10. So if I should run this code now, it starts from what? 8, jumps 6, goes towards 4, jumps 2, goes towards 4, right? Jumps 6, goes towards 8. But it can't go to past 10 already. So that is exactly how slicing works. So you can by using this method. There's another one. If I should choose not to put all these things here, all right, and just put from let's say from 3, index number 3, automatically Python will start from index number 3 and print the remaining that are there as the value of what? This new list. So if I should run this code now, you're going to have from what? Index number 3, which is 0, 1, 2, 3, which is 4. So it's going to have 4, 2, 4, 6, 8, 10. The same thing goes when you say you want to print from the beginning of the list and print up to 6. Close that. So it starts from the beginning and ends at what? The 5th index. Remember, this is going to be A, right? So it's going to stop at the 5th index. I can see 0, 1, 2, 3, 4, 5. The 5th index was 4. So that's where it stopped. It stopped at what? 4. All right. So that is how slice works. So we can also check if numbers are items are in a list. All right. We can also check if items are in a list. So for example, if we have this custom list here, so we want to check whether 5 is in my list. So it's 5 there. All right. It's going to give you true or false. So I should run this code now. 5 in the list. True or false? False, right? Is 5 not in the list? True. Or 5 is not in the list. 12 is in the list. True, right? So that's how these booleans work in with lists. Um, let's see if So we can also have lists inside a list. All right. We can also have a list inside a list. So for example, here I can have new list equals, so we have 1, 2, I can use my list. All right, so automatically my new list, let me erase this. So I'm going to print new list. You see that this my list is going to be contained inside here. Now you can see that we still have this. Let's say print 1 in my list. Let's see what this gives us. It gives us what? False. Because it does not, 1 is not in my list, right? So what if we check whether it's a new list? All right, is 1 in new list? True, right? What if we check if a value that was inside my list is in this new list? Let's say we check 0. So it says what? 0 is not a new list, because the list automatically, Python sees this as a whole value. This my list as a whole value, not individual values inside. All right, so Python is not looking at inside that list, it's looking at this as a whole value. Almost out of time. I think we're done with module 2. The only thing here are arrays. All right, let's just touch arrays so we can conclude today's class. And the next class we'll deal with module 4. So arrays just works like the way chess works. All right, so now chess is A1, B2, B3, A up to H, and a board position from 1 to 8, right? So you know A1, A2, A3, move pawn to B6, all those kind of moves. So that's how chess. So chess works with arrays, all right? So where each cell is looking like a two-dimensional array. So we can say, let me, so let's assume that a predefined symbol named empty, all right, is designated to the board. So we'll have this, right? So our board is first of all empty. But now for I in range 8, empty, we're going to put empty for I in range and append it. All right. We're not done yet. Let me delete this. So we're going to add so we're just, remember I didn't define empty in the beginning. So this is going to give us an error if I should run the code because empty is not defined. So I'm just trying to show you a mini code of how a chessboard would likely be produced. All right. So if we want to create a list now of lists representing the whole chessboard, we can now use this particular code here and now say for I in range 8. So for row, you are going to put empty for every value of I. So which means that for the row, you're going to have empty, empty, which means the chessboard is actually empty. So we're going to now append empty for all the row for the range of I, right? So that's from starting from I from the beginning of the chessboard to the last row, which is 8. So we're going to, the whole chessboard is going to be empty. And then we can also have the same value for the column. All right. Or we can also even print items. All right. So what if we wanted to put some kind of items inside each cell? Okay. So we already have rows and columns, right? For that's for J, right? Printing empty for every column in J. So we now have empty for empty in A1, A2, A3, A4, B1, B2, B3, up to BH8, right? Everything is empty. So what if we wanted to print, put different items inside? We now say board. On the board now, 00, which is what? On the board, 00 is A1, right? Put a rook. 07. 07 is A7, right? That's on the chessboard. I don't know if you can picture what I'm saying in your mind, you understand better. So you're going to print what? Another rook. So you put the value of a rook there, you can put a pawn. So that's how you fill in all the values or all the pieces inside the chessboard. And when you want to move an item, you now say this particular one now equals, you put the new board number there. All right, the rook will now will now enter into a new board number, and that previous board space becomes what's empty. I don't know if that, so that's just how the chessboard works. Maybe in our next class we'll look at more examples on these lists or arrays so that we can understand how arrays work. So do you have any questions before we call it a day? Do you have any?
I'm okay.
All right. All right. Let me stop this.